Hello everyone, welcome back to the Quick Machine Tutorials. In this tutorial we will be looking at FEMM, Finite Element Method Magnetics. Now again, Quick Machine is really just an interface into FEMM, which actually does the finite element analysis. So in this tutorial, I'm assuming that you've created your model, you've set the geometry, you've created the phases, and now it's time to analyze. So here you hit the analyze button, and in a few seconds you'll end up with hopefully something like this, some sort of FEMM model. Now in this tutorial we're going to be looking at some of the cool things that you can do with FEMM that will help in your analysis. And this is by no means exhaustive. If you are interested, and you should be, just go up to the help topics here in the FEMM model or the FEMM program, and you'll have a very comprehensive user manual that will help you with any of your specific topics that you may need. So the most obvious thing that you're going to do at first is try to figure out what the torque is acting on the rotor. So in order to do that, you have to select the rotor. Now there's three selection modes in FEMM. There's a point select, a line or arc select, and a block select. So right now I'm in the point select mode. So if I click somewhere here, I'm selecting a point. I'm not selecting, so right here this tells me what point I'm actually selecting. Now if I were to hit this line or arc select, I click two endpoints, I then select the line. Alright, so if I can continue to select lines and arcs that way. But let's just go ahead and select a block, which counts as any enclosed space. So for instance, the rotor is a block, this winding area is a block, the stator makes up a block, the air gap makes up a single block. So let's go ahead and select the rotor. Now we need to perform a torque via weighted stress tensor integral over this selected block. Now this integral actually only works if you have air surrounding the rotor. So as long as you have air in your air gap, so again, here's where you actually set the materials. So you need some sort of air boundary in here in order for this integral to work. So if I hit OK, it immediately comes up and tells me how much force I have acting on the rotor. So here I have a negative about 40 Newton meters acting on the rotor. Now, one of the other things that you might find useful is to look at the flux density plots. So in order to show the flux density plot, hit this button right here and show density plot and hit OK. Now you'll see with these nice colors what the actual flux densities are, and this gives you a legend for these flux densities. Now what you can do is you can zoom in on certain spaces. So you hit this zoom in button and you automatically zoom in. You can use these arrow buttons to sort of move around. So if I want to look at a specific spot, perhaps maybe like the interaction between a stator tooth and rotor lobe, you can see these flux densities here. Now if I'm in the point select mode and I click somewhere in this flux density or somewhere in the stator tooth, and you look at this FEMM output, you're going to see a number of values that you have here. So you're saying that the total flux density at that point that I selected is 1.7 Tesla. Right. So the flux density in the X direction is this, the flux density in the Y direction is this, and it gives you a whole list of other parameters that you might find useful. Now, when you're done zooming in, you can hit this button right here and it brings you back out into this zoomed out mode. Now, another thing that you might want to look at when you're using FEMM is the circuit properties. So right here, you have a list of circuit properties. So here you get to choose what phase you want, phase A or phase B, and these phases will match what you've listed here. So right now we have phase A is firing, as you can see here. So we're going to have 20 amps firing in phase A, and again, that's what we've set right here. So this just gives you a number of different properties that you can use for whatever type of analysis that you might want to do. Note that phase B is completely turned off. As you can see in this picture, phase B is turned off, and that's reflected by this data here. Alright. So again, this is just a list of a few things that you can do with FEMM. If you want some more detail, please consult the user manual that goes along with it. This will give you a very detailed description of everything that you can do. Also, a simple Google search in many cases will lead you to the right answer as well. So again, thanks for watching, thanks for using Quick Machine, and I will see you next time.